everyone, so here's the solutions to the review for your quiz tomorrow. So on number 1, this is just a regular linear equation, so we're just going to go ahead and distribute. If you distribute through here, you're going to get negative 6x plus 15, then plus 6 equals, distribute this, you're going to get 20, oh, that looked awful, sorry, 20x, and then minus 5, okay? Now let's go ahead and combine some like terms on the left-hand side. So if we combine the negative 6x, no, let's try that again. The 15 and the 6, 15 plus 6 is 21, so we're going to get negative 6x plus 21 equals 20x minus 5, okay? Now, moving stuff over to get the x's together, I always like to move the lighter one, so I'm going to go ahead and add a 6x to both sides. You're more than welcome to subtract 20x from both sides. That'll work as well. Okay, so for that, we're going to end up getting 0, and then 21 equals 26x minus 5. Then if we add 5 to both sides, we're going to get 26 equals 26x. And if we divide by 26 on both sides, we're going to get x equals what? Okay, so there's number 1. All right, number 2. You guys still linear, but a little gross. I don't know about you, but I'm not too hot about this 4 and this 2. If they weren't there, my life would be a lot easier. So let's get rid of it, okay? So I know that the common denominator for 4 and 2 is just 4. It's a number that both of them go into. So what I'm going to do is I'm going to multiply all of these terms by 4. I have to do it to every single term, though, to keep my equation balanced, okay? So in the first one, the 4 and the 4 are going to cancel, leaving me with a 3n. Don't forget the n. Do you see that there? Okay, then here, nothing cancels. This is just multiplication. So 2 times 4 is 8. In this one, I have 2 goes into 4 twice, and 2 times 1 is just 2. Don't forget your n. And then 7 times 4 is 28. Okay, so look, I got rid of that 4 and the 2 that I didn't want. Now it's just combining like terms. So again, I'm going to move the lighter load, so I'm going to subtract 2n. This goes away. I'm going to have 1n minus 8 equals 28. And if I add 8 to both sides, I'm going to get n equals 36. Okay, so you guys just expect one question tomorrow that's a linear, something like one of these two, okay? Okay, solve by factoring. Please make sure that you pay attention to the actual instructions here. So on this one, oops, that's not what I want on a highlighter. On this one, I want to factor everything, okay? That's what it's telling me. Not quadratic formula, not completing the square, it's telling me to factor. So how do you factor this? First of all, you guys, before you factor anything, make sure it's equal to 0. It is, so I'm good to go. Okay, this is just GCF factoring. So I'm going to pull out a d. That leaves me with a d minus 5 equals 0. And then I'm going to go ahead and set each factor equal to 0. So the first one is going to be d equals 0. That is one of my answers. And then the other one, d minus 5 equals 0, which just gives me d equals 5. And you guys kind of keep in mind highest exponent. Oh my gosh, I keep hitting the wrong thing. Highest exponent here is a 2. Okay, I think I just can't do technology today. The highest exponent is a 2, which means that you should have 2 solutions. Now, it could be the same number, like d equals 5, but there needs to be 2 solutions, okay? All right, number 4, what kind of factoring do we have here? So on this one, this is big star. So let's draw a really big star. So I need 2 numbers that multiply to give me 16, add to give me negative 17. Okay, that would be negative 16, negative 1. And then I'm going to divide by the leading coefficient, which is my 4. And then let's go ahead and reduce these guys. So this reduces to negative 4. That's one of my factors. And this does not reduce, so I'm going to leave it negative 1/4. So this guy factors to a minus 4 times a minus 1/4 equals 0. And again, setting each factor equal to 0 is going to give me a equals 4, and then a equals 1/4. Again, I had a degree, or the biggest exponent, that was a 2, which means I should have 2 answers. Okay? All right, let's look at 5. Okay, there's something really wrong with this one. And what's wrong with this one, that it's not equal to 0. So I need to move this over, giving me n cubed minus 9n equals 0. Now let's factor. Again, this is going to be a GCF. So if I pull out an n, I'm left with n squared minus 9 equals 0. Now at this point, you could set both factors equal to 0, or you can keep factoring. Check it out. I could go, this guy right here is a difference of 2 squares. That factors to n plus 3 and minus 3. So there's 2 ways you could do this problem. I don't really care which way you do it. Okay, now setting all of these factors equal to 0. There's 3 factors. Holy moly. So I'm going to get n equals 0. There's one of my answers. This one gives me n equals negative 3. There's another one, and this one gives me n equals 3. There is the last one. And again, you guys, look, you should always be double checking this. The highest exponent here was a 3, which means that you should have 1, 2, 3 answers. Okay? If you're missing one, you probably forgot a plus or minus somewhere. Okay, let's look at 6. All right, is it equal to 0? No, it's not. So let's do that. Let's move the 12 over. So this is going to be x squared minus x minus 12 equals 0. Okay, this kind of factoring, that's just big ol' x. So I'm going to have a negative 12 on the top, negative 1 on the bottom. This is negative 4 and positive 3. So it's going to factor to n. It's not an n, though. X minus 4, and then x plus 3. Uh-oh, I have a low battery. That's not good. Equals 0. Okay, setting each factor equal to 0. See, now I'm panicked. What if I don't get to finish this? X equals 4, and x equals negative 3. And again, you guys, looking at this, right? The biggest exponent that I saw here was a 2. I have 2 answers. Hey, you guys, I'm going to relocate and move next to my charger so my iPad doesn't die, because that'd be really sad. Will this charge it? Hang on a second. Are we charging? I can't tell. Let's hope so. Okay. Now to sit on the ground next to my charger. Oh my gosh. Okay. All right, number 7. Now, again, read the instructions. It says solve the quadratics by completing the square, okay? So completing the square, what do? We need to make sure that the leading coefficient is a 1. So look, the number in front of this x squared is a 1. I'm good to go, okay? And the middle number is even, so this should not be so bad. So step number 1 is to move the 120 over. So I'm going to have x squared plus 2x equals 120. Okay, now I need to find the term that completes the square. So I'm going to take this 2. I'm going to cut it in half and square it. So 2 over 2 is 1. 1 squared is 1. That means I need to add to both sides of the equation, right? Again, I'm doing it to both sides because I have to make sure that the equation's balanced. Okay, 120 plus 1 is 121. And then this right here, we're going to go ahead and factor that. That's just big X. So I need 2 numbers that multiply to make 1 and add to make 2, which is 1 and 1. So this is going to be x plus 1 times x plus 1, or shorter way, x plus 1 squared. Okay, now let's go ahead and take the square root of both sides. The square and the square root cancel out, so I get x plus 1 equals, don't forget your plus or minus when you're squaring both sides. If you do, you're only going to get one answer, okay? And square root of 121 is 11. And if I subtract 1, I'm going to get negative 1 plus or minus 11. Now, this is actually nice, so I need to work it out. So it's x equals negative 1 plus 11, or x equals negative 1 minus 11. Negative 1 plus 11 is 10. There's one answer. Or negative 1 minus 11 is negative 12. There's your other answer. Okay? Now, you guys, some of you might be thinking, Screwsy, I just could have factored number 7. That would have been so much faster. Yeah, but I wanted you to complete the square to see if you could do it. Okay, let's look at number 8. Again, leading coefficient is a 1. The 8 is even, so I'm kind of good to go. So let's go ahead and subtract the 11 from both sides. So I'm going to get x squared minus 8x equals negative 11. Now let's find the term that completes the square. So it's going to be determined by this negative 8. So I get negative 8. I'm going to cut it in half and square it. which gives me negative 4 squared, which gives me a positive 16. So I'm going to go ahead, yikes, add 16 to both sides. Okay, and then what do we get? So this right here, negative 11 plus 16, that equals 5. And then if I go ahead and factor this, I need two numbers that multiply to make 16, to give me negative 8. That would be negative 4, negative 4. Again, they have to be the same there. So it's going to be x minus 4 times x minus 4, or x minus 4 squared. Take the square root of both sides. Square and square root cancel. I'm left with x minus 4 equals, don't forget your plus or minus. And then last but not least, I need to add the 4 to the other side. So I'm going to get 4 plus or minus the square root of 5. And you'll be wondering, that's only one answer. No, it's two answers because of the plus or minus, right? Whoops, that's not a highlighter. The plus or minus gives you two answers, right? 4 plus square root of 5, 4 minus square root of 5. So again, degree of 2, two answers. Okay, now you guys, number 9, x squared minus 14x plus 60. Okay, so you guys, this one right here, again, I'm going to move this 60 over. So I'm going to get x squared minus 14x equals negative 60. Then I'm going to go ahead and complete the square. So on this one, I'm going to look at the 14. So I'm going to take negative 14 divided by 2 and square it, which gives me negative 7, that whole thing squared, which gives me a 49. Okay, so I'm going to go ahead and add 49 to the left. I'm going to add 49 to the right. Go ahead and simplify this. So negative 60 plus 49. Wow, that was really big. Negative 60 plus 49. That's going to be, let's see, 60 minus 49 is negative 11. And then this guy right here, if I factor that, I'm going to end up getting x minus 7 times x minus 7, or x minus 7 squared. Okay? And taking the square root of both sides, I'm going to run into a little problem here. I wonder if you guys can see it already. It's going to give me x minus 7 is plus or minus the square root of negative 11. Okay? Now, I'm going to stop right there. Can you take the square root of a negative number? Well, some of you can, but some of you can't because I haven't taught it to you yet. So if you ever have the square root of a negative number, you can just write no real solution. But you guys, tomorrow on your quiz, it will be a solution. I'm not going to do square root of negative, okay? And then let's try number 10. So number 10, a little gross, but we can deal with it. I cannot have a 2 as a leading coefficient, okay? So what am I going to do with that? I'm going to go ahead and divide everything by 2. It's going to cause a little bit of chaos here, but it's not too bad. So this cancels out, leaving me with x squared minus, and then here I'm going to have this 8 over 2, which reduces to 4. And then I have this minus 5 over 2 equals 0 divided by 2, which is 0. I know you don't like the 5 over 2, but it is what it is. You have to just deal with it, okay? So step number 1, move it to the right, which gives me x squared minus 4x equals 5 over 2. Now let's complete the square. Let's look at the negative 4. So I'm going to take negative 4 divided by 2 and square it, which equals negative 2 squared, which is 4. So I'm going to go ahead and add 4 to both sides. Okay, now doing some fractions here, you guys, I know you can do it. Okay, this is like 4 over 1, right? I need a common denominator of a 2, so I'm going to go ahead and multiply both of those by 2, which really gives me 5 over 2 plus 8 over 2, which is 13 over 2. I know it's gross, but just deal with it. Okay, and then this one right here, what is that factor to? If I do a big X on that, I need two numbers that multiply to give me 4, add to give me negative 4. That would be negative 2, negative 2. So this is going to be x minus 2 times x minus 2, or x minus 2 squared. And then to get rid of the square, I'm going to take a square root, cancel, which gives me x minus 2 equals plus or minus the square root of 13 over 2. And then just move the 2 to the other side, so I get x equals 2 plus or minus the square root of 13 over 2. Okay? Kind of ugly. Be nicer on the quiz. All right, now let's look at the back here. Solve the following using the quadratic formula. Well, we need the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you guys remember, this must equal 0 before you actually start plugging in your variables, okay? So be really careful. Okay, this does not equal 0. I need to move the 18 over. So I'm going to have r squared minus 7r minus 18 equals 0. Now, some of you might be like, but it says x equals in here. You guys, this x right here is whatever the variable is. My variable is r, so I can say r equals. It doesn't really matter, okay? So write out what your a, b's, and c's are. So my a is the number in front of the r squared right here, which is an invisible 1. My b is the number in front of the r, which is that -7. Don't forget the negative. And my c is this constant, which is the -18. Okay, so let's go ahead and plug it in. So it's r equals negative b. b is -7, so that double negative is going to make it positive, plus or minus the square root of b squared. So I have -7 squared. And then I have minus 4 times a times c, which is -18, all over 2 times a. Okay, let's do some simplifying. So I have r equals a negative and a negative makes a positive, plus or minus the square root of, and then I'll just highlight as I go here. -7 squared is 49. And then looking here, I have a negative times a negative. I know that's a positive. And then I need to multiply these out. Now, some of you may be like, I don't know how to do that. I need to do 4 times 1 times 18. Okay, well, 4 times 1 is 4. What's 18 times 4? If you don't know, just work it out. 18 times 4, 8 times 4 is 32. Carry the 3, that's 4 plus 3, which is 7. That wasn't really that bad, right? Okay, and then all over 2 times 1, which is 2. Okay, let's keep simplifying. Okay, what is 49 plus 72? So that's going to be 7 plus or minus 49 plus 72. Looks like it's 121 all over 2. Hey, that's nice, right? Isn't the square root of 121 a thing? It's 11, isn't it? So this is 7 plus or minus 11 over 2. And then you guys, if it comes out pretty, you got to keep going. So this is either 7 plus 11 over 2, which is 18 over 2, which is 9. So there's one of my answers. Or it's going to be 7 minus 11 over 2. 7 minus 11 is -4, divided by 2 is -2. So there's your 2 answers. And I saw many of you did this in class today and you did a great job on it, so good job. Okay, number 12. Okay, so it's equal to 0. Let's label our A, B's, and C's. A equals 3, B equals -7, and C equals -2. Remember, A, B, C. Okay? So x equals negative b. So negative b, which is -7, plus or minus the square root of b squared, minus 4 times a times c, and then all over 2 times a. So again, simplifying here, a negative and a negative makes a positive, plus or minus the square root of, do some highlighting here, -7 squared is 49. And you guys, again, we've got this negative times a negative makes a positive. And then this is a little bit easier to multiply. 4 times 3 is 12. 12 times 2 is 24. So a little bit easier. That's a massive square root. And then 2 times 3 is 6. And then keep going. This is 7 plus or minus. If I go ahead and add these up, I'm going to get the square root of, let's see, I think that's 73. Is that correct? Wow, that's really big. And then all over 6. And you guys, I'm just going to leave it. I have no idea what that is, so it's all good. Does that make sense? Okay, you guys, remember these will be on your test, but they're not going to be on your quiz tomorrow. So I think I told you guys to skip these for now. Don't worry about doing those. Okay, now these are kind of important though, right? Okay, I think we did 16 in class together. So you guys, I'm not going to do that one again, but let's go ahead and do number 15. So what I want to do on these is I always want to factor first. So see if there's anything on the bottom that factors, like this one. Okay, that's just a GCF factoring. So this would be 3 over x times x plus 3. And then let's rewrite everything else because nothing else factors, right? Okay, now what's my common denominator here? Well, my common denominator, if you look at this, I'm going to go ahead and highlight this so you can see what I'm talking about. Okay, there's a denominator that has an x, another one that has an x. So if anything repeats, write that down once. So one of my common denominators is x. And then you guys, another common denominator is this x plus 3. They both have that in common too. So x times x plus 3 is your common denominator. So what I'm now going to do is multiply everything by that common denominator because it's going to cancel them all out, which will be really nice. Okay, so check out what's left over. Okay, the x cancels with the x. The x plus 3 cancels with the x plus 3, leaving me with a 3. I love that, okay? The x plus 3 cancels, leaving me with an x times all of this, which is x plus 2. Notice how I'm taking the time to write it out so I don't make mistakes. And then this cancels, leaving me with 1 times x plus 3. Now it's just a linear equation, kind of like number 1. So let's go ahead and do this. I'm going to have 3 plus, if I distribute the x, that gives me x squared plus 2x equals, distributing the 1, that's kind of silly, x plus 3. Okay, now let's go ahead, because there's an x squared, let's set it equal to 0. If I subtract 3 from both sides, the 3's cancel on both sides. If I subtract x on both sides, this is interesting. I'm going to get x squared, 2x minus 1x is 1x. And x minus x is 0. Now, you guys, this is a problem very similar to the factoring one we did here. Which one was it? Oh my gosh, like number 3. Very similar to that. You just pull out a GCF. It's so easy that it's actually almost hard. So if I factor this right here, pull out an x, and I'm going to be left with x plus 1 equals 0. Now, setting each factor equal to 0, I'm going to get x equals 0. And then x plus 1 equals 0, which if I subtract 1, I'm going to get x equals negative 1. Now, you guys, look, before you get all excited and go, there's my answers, I'm done. Okay, be careful. Make sure that those answers actually work. Can x equal 0? Well, look here. If you plug it into there, I'm going to have 1 over 0. I cannot divide by 0. Nope, that's a bad one. Can x equals negative 1? Yeah, I can plug negative 1 into there. I can plug negative 1 into there. It won't give me a 0. I'm good to go. Okay, and you guys, since this is a combination of both of these, okay, I don't have to check the third one. All right, so just x equals negative 1. Okay, now number 17, 2 ways you could do this. If you have a proportion, the way I like to do this is just to cross multiply. But you guys, it's only going to work if you have fraction equals fraction. It won't work on something like 18 because you have 2 fractions equals a number, okay? So let's go ahead and multiply that. So I'm going to have 1 times x minus 5 equals 2 times 3x plus 4. Let's go ahead and distribute. That'll give me x minus 5 equals 6x plus 8. I always like to move the lighter load. Let's go ahead and do that. So you get negative 5 equals 5x plus 8. And then go ahead and subtract 8 from both sides. That's going to give me negative 13 equals 5x. And then if you divide by 5, you're going to get x equals negative 13 over 5. Alrighty? And you guys, again, if you plug that into here, I'm good to go. If you plug that into here, I'm also good to go. It will not give me a 0. Okay, number 18. Oh, I don't like these denominators. Let's find a common one. So the common denominator here, they have nothing in common, by the way. So the common denominator is just going to be x times x plus 2. If you can't figure out what the common denominator is, just multiply the 2 denominators together. So let's multiply this by x times x plus 2, this by x times x plus 2, and this by x times x plus 2 as well. Every single term has to have it, okay? The x's cancel, leaving me with a 2 times x plus 2, minus the x plus 2 cancels, leaving me with a 3 times x, and it equals, you guys, the 1's kind of irrelevant because 1 times anything, it's the same thing, but I do have this x times x plus 2 left over, right? Okay, let's distribute. So I have 2x plus 4 minus 3x equals x squared plus 2x. Okay, you guys, I see something kind of cool here. Look, if I subtract 2x from both sides, what happens to them? they cancel out, right? If you have something on one side of the equation that's the same as the other, they always are going to cancel out like this. So I have 4 minus 3x equals x squared. Now, because I have an x squared in there, the strategy here is make it equal to 0 and then either factor, complete the square, or quadratic formula. So because the x squared is already positive there, I'm actually this time going to go ahead and move the 3x to the other side. So I'm going to have plus 3x. Does that make sense? And then to move that 4, I'm going to subtract 4, and that's going to cancel out. So my new equation is really 0 equals x squared plus 3x minus 4. And again, you guys, the strategy with any quadratic is to factor, complete the square, or do quadratic formula. Will this factor? I sure hope so. Two numbers that multiply to give me -4 and add to give me 3. Oh my gosh, it works. 4 and -1. So this factors 2x plus 4 times x minus 1. And then setting each factor equal to 0 is going to give me x equals -4 and x equals 1. Now, you guys, do those work. Let's look at the original problem. Would x equals -4 be a problem? Look, this used to be an x. If I plug a -4 in there, that's not 0. This was x plus 2. If I plug a -4 in there, -4 plus 2, that's not 0, so I'm good with the -4. Can I plug in 1s? Yep, that would give me 1 and 3. I'm good to go. So these are both going to be your answers. Okay? So you guys, I hope that helped. We'll have about, 10 minutes to ask questions tomorrow if you have anything. Okay? Have a good day.